Our next lecture on section 2.2 is on the fundamental theorem of fractions and how we are going to use that to make another type of equivalent fraction, one that we call building a higher term. We already used the fundamental theorem of fraction to reduce fractions in order to make an equivalent form. So here we go. The fundamental theorem of fraction says that if I have some fraction a over b and I multiply both the numerator and the denominator by some number c, that's some non-zero number by the way, or if I divide it by c, and the numerator and the denominator, I'm going to end up with a fraction that is equal to a over b, and we see that in both of these terms. So whether I multiply numerator and denominator by the same number or whether I divide them by the same number, I end up with an equivalent fraction or an equivalent form. We saw the use of the a divided by c and the b divided by c equaling an equivalent fraction when we were learning to reduce fractions. Now let's see this visually because we didn't see that before. So to build an equivalent fraction or to reduce to an equivalent fraction, what we're seeing is that we have visually the same representation. 1/4 and 2/8 are exactly the same representation. Here you see a figure of equal size to this figure down here, but the top figure is divided into 4 pieces, denominator being equal to 4, and over here it's divided into 8 pieces, denominator being equal to 8. Here I've shaded 1/4 of this figure, and that's its representation. Here I've shaded 2/8 of the figure, and that's represented. And what you see is the exact same portion being represented here. That's the meaning of equivalent fractions. So whether I have 2/8 and I say that it's equivalent to 1/4, or 1/4 and it's equivalent to 2/8. We started by having 2/8 and moving back to 1/4. Now our job is going to have 1/4 and move up to 2/8. And we certainly need a different way to do this than just a visual representation. And so that's what we learn to do by reducing fractions and building higher terms. Our job now is to build the higher terms. So this is how we're going to do it. This first step is in creating an equivalent fraction. To build the higher terms, we need to know the new denominator. So we're going to decide that, or we're going to know it. Now in just a little bit we're going to learn how we decide. But first we're just going to be told. And then we're going to use division, or we're going to use an idea of a missing factor problem to find out what the c is going to be used, so we can use the fundamental theorem of fractions. And then we're going to multiply both the numerator and the denominator by that c, and we're going to rewrite the fraction. So example 7 here, we're just going to show that. So first off, I'm going to set this up to show you how I would be rewriting it. So 2/3 with a new denominator of 9. So 2/3 is going to be equivalent to a new fraction over here with a denominator of 9. Now when you do this in basic math, you usually are just told this kind of problem. So now here's where the division or the multiply by what, the missing factor idea comes in. So 3 times what is equal to 9? Or another way of asking that, 9 divided by 3 is equal to what? So that what is a 3. So 3 times 3 is equal to 9. That's our c. That right there is our c. So what we do to the bottom, we do to the top. And yes, I do want you to write it that way. 2 times 3 is equal to 6. And now we have our equivalent form. We have built the higher term. Our next one, 8/15, we want a denominator on that one of 30. So I'm going to put the 30 over here. And now I say to myself, 15 times what is equal to 30? Or 30 divided by 15 is equal to what number? So that is going to give us a 2. And so this again is our c. And so this goes up here as well. 8 times 2. And 2 times 8, or 8 times 2, is equal to 16. And now we've created our equivalent fraction, or we've built the higher term. And that concludes how we're going to build higher terms. And now we're going to use some of these things.